So welcome to virtual GED class. Today we're talking about circles. We're still going to look at perimeter and area. What does that look like in the world of circles? How is it the same? How is it different? We'll branch a little bit even into some volume and surface area problems, which will be pretty simple. And we'll do some of those backwards type problems where we start with the area or the perimeter and then we move backwards from there and find a missing dimension. So definitely everything we do today is fair game for the GED. We'll do from very simple to pretty complex circle problems today, and we'll be across the board there. Okay, so first thing, we need a definition of a circle, and that's my favorite because whenever I ask students what a circle is, they're like, it's a thing. It's the round thing. What's a circle? It's a round thing, Kate. Okay, so the technical math definition is the circle is all the points, and this is a weird definition. Don't worry, I'll explain it. Equidistant. Who do we have? Bianca, welcome, welcome. So all the points equidistant from another point, known as the center. So a circle has a center point, but that circle itself, or that center, is not the circle. The circle is all the points that are equidistant from the center. Anybody know what the word equidistant means?
Well, in distance?
Yeah, definitely. We see distance in it. And yep, that's definitely distance. How about equi? What does equi sound like? Sound like any words we know? What?
Equal?
Absolutely, exactly. Equidistance means in equal distance. So a circle is all the points equal distance from a center. So like, for example, if I came out like 2 inches here and I made a point, but then I found all the points that were exactly 2 inches away. So like 2 inches away this way, and 2 inches away this way, and 2 inches away in any direction, I can go out 2 inches from this center. And if I found all of those points, they would draw a very lumpy looking circle if you're me, but usually a straight circle. Does that make sense? All the points equidistant from a center is a circle. That's the official definition. Are we good with that? Mm-hmm. Okay, a couple pieces and parts of a circle that we need to be familiar with in order to progress. Okay, so that distance that we were just talking about from the center to the outside edge of a circle has a name. Does anybody know the name of the distance from the center to the outside of a circle? Absolutely. Bianca says, is it radius? It sure is. That is the radius. It goes from the center, it goes out. But remember what we said, that all the points are equidistant. So anywhere on the circle, it's equidistant. So it wouldn't matter where I drew that. I could draw it right here directly across. This would be another radius right here from the center out onto the left. Does that make sense to you guys? So I could see anywhere from the center to the outside is known as the radius. And then we have another name, and students mix these two things up a lot. There's an actual name for when you go all the way across one side to the other through the center. So it looks a lot like those two radiuses. That is known as the diameter of a circle. And you just cannot get around it. This is vocabulary you just need to know for the test. You just need to know that a radius is, you know, from the center to the outside. The diameter is through the center all the way across. And then you need to see the relationship between these two. Can you see it? Diameter's related to radius. How? Well, when I drew two radiuses, one going this way and one going that way, it added up to a diameter. Can you guys see that based on the picture? Good. So I'm going to say this. I'm going to say the diameter is twice the radius. It's like two radiuses put together. Do we call those radii? I don't know. Okay. But the diameter is twice the radius. And conversely, I could flip that around and think of that the other way. The radius, what would be the relationship of the radius to the diameter? Exactly. Bianca said, is it half the diameter? The radius is half the diameter. Okay, so this is a relationship that the GED will assume you know. All of these things we've just talked about, this vocabulary, this language, they'll just assume you know. And so it could be included in a problem. It could come up. You could have to flip back and forth between diameter and radius with no formula, no nothing. You're expected this knowledge based on definition. Is everybody cool with that? Okay. Only one other thing I have to introduce to you before we try all these typical style problems, and that is a new number. And that is why I often title my circle lesson, I'm sure you guys saw it in all my bad jokes, because mathematicians make bad jokes. I call my circle lesson pi, because you can't talk about circles without talking about the number pi. I think that's Bianca. Okay. So the number pi, we don't usually spell numbers in math class. We usually use a symbol to stand in for a number. So the number pi is written like this, two little lines with a curvy little top. And I'm sure you guys have seen it before. Now, I ask students all the time, do you know what pi is? And they say, I know what pi is. Pi is 3.14. That's the answer I get the most. And Zerenity's clearly been in my class because I like to holler about this. Pi is not 3.14. Pi is kind of close to 3.14, don't get me wrong, but he's not exactly 3.14, okay? Pi is what's known as an irrational number. Now, you don't have to memorize this word irrational number. That won't come up on your GED, though it will come up in your college math classes. But you should understand what I mean when I say pi is an irrational number. What I mean is that his decimal form goes on and on. I shouldn't say his. I love to turn numbers into people. But an irrational number is a number whose decimal form goes on forever with no pattern. Okay? So that means that the decimal form of pi would have decimals until the end of time. 3.14159, and those are all the ones I know. I don't have any more memorized. But there are, in fact, pi decimal memorizing competitions. That is a thing. So if you care to spend the next 10 years of your life memorizing like 3,000, 4,000 decimals of pi, you could participate. Okay, that's how ridiculously long pi is. It goes on and on and on forever. Do you know how much fun it is to do math with a number that has an infinite number of digits in it? It'd be no fun. Okay? You don't want to carry 3.14159 and on and on and on and on and try to do math with that, especially multiplication and division. You would be in hell. Okay? You'd be multiplying till the end of time and you'd never stop. And that is why we often use approximations for pi. What do I mean by the word approximation? Close enough to give us a decent answer. Close enough. Maybe not perfect, not exact, but close enough. The most common one you're going to see on the GED is the decimal approximation. So that's probably why you've heard it. A lot of GED teachers like to use, or a lot of math teachers just teach you like 3.14 is pi. But all it is a decimal approximation. It's rounded, it's close enough. We're going to get a good enough answer. And so we'll often use it. Does that make sense to everybody? But do realize that this is a decimal approximation. It's not perfect. It's not pi. It's close to pi. Okay? But that's not the only approximation for pi, by the way, guys. There's a fraction approximation for pi, and some of you go, dear Lord, why would I ever want to use a fraction approximation? How disgusting. Well, in some problems, and it doesn't happen on the GED, so I won't do it for you now, but I guarantee you'll see this if you do this subject in college. Some problems have fractions, and so it's easier to, instead of doing a fraction and a decimal together, to have two fractions together. And so you might at some point in your career use a fraction approximation for pi. Again, nothing you need to have memorized, just something you should be aware of exists. Now that we have all this information, we can try to do some problems as we would see on the GED. But I do need to warn you of one thing. Using an approximation means that the answer that we get will not be exact. And so my warning to you is that sometimes the GED or your math teachers might require an exact answer. The only way to have an exact answer, since all the numbers that we have are approximations of pi, is to use the symbol pi. And so sometimes pi will show up in the answer, and that stresses students out. But we're going to look at some problems like that today. We're going to look at all different kinds of circle problems, from simple to hard, and in all different kinds of ways. And I think that I'm setting a record today for the most example problems, but it's just because there's so many tricky circle issues that could come up on the GED, and I don't want you to be fooled by any of them. Example number 1 here says, what is the area of a circle to the nearest tenth of a square foot with a radius of 4 feet? Okay, so they've asked me to find area. They've given me radius. And there's one more thing I want to point out to you in this problem. This phrase, to the nearest tenth of a square foot. So they've told me to find area. They gave me radius. And this phrase, the nearest tenth of a square foot, is rounding language. It says to the nearest tenth of a square foot. You just got permission to round. Does that make sense? Yeah, exactly. And so the second I see that language, I know it's acceptable to use approximation for pi. I've been told to round anyway. Why don't I just use an approximation then? Okay. And so that is what I'll do. So let me first start with the appropriate formula. I asked you guys to bring your GED formula sheets to class today. Why? Because if you did this on the GED, you'd have the formula sheet. You don't have to have this memorized. So I need the area of a circle formula. Anybody brave enough to read that formula to me?
A equals pi r squared.
Exactly. And I love how you read that. You read that like a mathematician. A equals pi r squared. Okay. Now, just as usual, the thing that I'm looking for remains a letter. So I'm looking for A, so it will remain A. Now, pi. You have a decision every time you see pi. Decision, approximate or not to approximate. Do I approximate or do I use an exact answer? And we had that rounding language in this problem, so we have permission to approximate. And so I am going to call pi by the approximate value of 3.14. Is everybody cool with that? Again, the only reason I'm doing it is because of this language here. It says to the nearest tenth of a square foot, I was given permission to approximate. Okay. Now, I know my radius, I'll plug that in. Notice that I plug in my radius with parentheses because the r is shoved up against the pi, it is multiplying. And now I'll put my little square on there. The great news is if you have your TI 30XS calculator, it will do order of operations for you. If you do not, you have to know the order of operations. Other calculators don't always do order of operations. So I'm using my TI, and so what I'm going to do, this entire expression has no letters left. I'm just going to type it into my calculator. So 3.14, open parentheses, 4, close parentheses, and do you guys know how to get a square? That's the x squared button. So I'll type the x squared button and it will square my 4, and I get that my area is equal to 50.24. Now, I don't want to do all this work and then get disqualified based on the fact that I forgot to pay attention like I did last video. Someone corrected me for it already on the internet. But let us follow any rounding directions we've been given. Very final step is to round. So we see that our final answer is supposed to be rounded to the nearest tenth of a square foot. The nearest tenth. How many decimal places is the tenths place?
2.
Oh, actually, tenths place is just 1 decimal. There's no such thing as once. So decimals start at tenths, then hundredths, and so on. So this first decimal place is my tenths. Does that make sense? Or maybe that's what you guys were saying, at the 2?
Yeah.
So I'm going to cut it after the 2. I'm going to examine the number I'm about to throw away, ask myself if it's big enough to matter. Am I halfway through my digits yet? And no, I'm not, because it's less than 5. So it'll drop off without making a difference. And we'll call that 50.2. 50.2 what? Well, we were finding area, so it's going to be measured in square feet. Very simple. Can these problems get trickier? Yeah. They sure can. Okay, Let's look at number 2. Now, some people get mad at me. They say, why in the world you said this? This was circles. Why am I finding the volume of a cone, Kate? A cone's not a circle. No, a cone is not a circle. However, you guys know what a cone is?
It has a circular top.
Exactly. A cone has a circle as part of it, okay? And so it's a three-dimensional shape, kind of like a pyramid coming down to a point that has a circle on the top, okay? And so circles do get involved, and so guess what? We see circles, we're going to see some pi, okay? You see circles, you see pi, period, okay? So hence all the bad math jokes on the internet about pi and mathematicians. So number 2 says, what is the volume of a cone? Now, we haven't done volume yet, so, and we'll talk about it more in a little more detail later, but I do want you to know that volume is a filling. It's filling up a three-dimensional space, therefore it is a 3D measurement. And we've not seen a 3D measurement yet. We saw a 1D measurement, perimeter. We saw a 2D measurement, area. Now volume, we're headed out in 3 dimensions. It's a 3D measurement. So what is the volume of a cone with a radius of 3 centimeters and a height of 5 centimeters? And it says round your answer to the nearest cubic centimeter. Okay, so in order to do this problem, I need a formula. I need the volume of a cone formula. Now this is tricky because when you go to look on your GED formula sheet, you're going to see under cone, there's 2 formulas, but only one of them is for volume. So anybody see the volume of a cone formula?
So it'd be V equals 1/3 pi r squared h.
There you go. V equals 1/3 pi r squared h. Now my students get mad at me because this looks like a complicated formula, but realize your TI is going to do the work. We're just needing to plug into it correctly. So volume is equal to, I got 1/3. Now this 1/3 and this pi are shoved together. So I'm multiplying by pi. So question now is, should I approximate pi or not? Should I approximate pi or not? Anybody see any clues in the problem that tell me whether or not to approximate pi? Kaylee says, yes, I agree with you. Why? How do I know I'm approximating pi right now?
Answer to the nearest cubic centimeter?
Exactly, that rounding language. Round your answer to the nearest centimeter. I'm rounding anyway. I might as well approximate pi, 3.14. Is that good? There is a pi button in your calculator as well. So it would pull up pi for you, even if you like totally flaked on what pi was. And then my r, my radius, I know. What is my radius?
3.
Absolutely, my radius is 3. So I'll plug in a 3 under my r. Now careful, my r was supposed to be squared. Don't drop the square as you plug in. And now I'll put my h in parentheses as well. It's shoved up against here, so it's multiplying. So my height, or my h, is what?
5.
5. And again, this entire expression is all numbers and operations. And whenever it's all numbers and operations, your calculator can do the calculations for you. That's just simplifying what your calculator can do. So I'm going to type the entire thing into my TI-30XS calculator. Okay. Now, there's a couple ways to type 1/3 in. Because my answer is expected in decimal form, not fraction form, I am going to remember that a fraction bar means the same as divide. And I'm going to type 1 divided by 3. 1/3 is the same as 1 divided by 3. Does that make sense?
Yes.
And then I'll open a parentheses, 3.14, close parentheses, open up a parentheses, 3, close it. Press that X squared button. To square my 3, open up a parentheses, put in 5, and close it. And I get out of my calculator a volume of 47.1. And if you guys have a TI with you, I highly suggest you try it too, because it sucks to get to the test and go, I know it was easy to use that thing, and for not know the buttons on your TI. Okay, I got 47.1. Final step for these problems, you should carry your decimals on till the very end, and then at the end we'll do any rounding we need to do. So I see rounding directions say round your answer to the nearest cubic centimeter. It doesn't say a place value. It doesn't say tenth or hundredth or ones or thousands or what. It just says to the nearest cubic centimeter. When it says to the nearest unit, any unit, I don't care if it's cubic centimeter, square feet, meters, yards, dollars, just about any unit, if it says that, you are going to be rounding to no decimal places. So knock it off right at the decimal. I want whole cubic centimeters. That's what I mean by that, whole ones. Does that make sense?
Yes.
Okay, so consider the number you're about to throw away. Is it big enough to matter? It is not, because I'm not halfway through my digits at 5 yet. And so I will just call that 47 cubic centimeters. Now, we haven't talked about cubic centimeters. We've only talked about square centimeters. You know, what did we say was measured in square units? Area is measured in square units. Area is the number of squares to cover. But now we're talking about volume. And volume fills up a three-dimensional space. So volume is going to be in a cubic unit. It's a three-dimensional unit. It's like how many little cubes would fill up this cone. Does that make sense?
Yes.
Okay, wonderful. So we get 47 cubic centimeters. These are still the straightforward problems. I hope you get one like this on the GED, but they don't usually do many straightforward problems. So number 3, also straightforward, but there's a little trick to the formula. So let's take a look. It says compute the circumference of a circle. Ooh, I forgot to define circumference for you at the front. I meant to. Okay, circumference, that's a new word. We've never talked about the circumference of a circle. Does anybody know what circumference means?
Is it
So
the
round?
circle?
Exactly. Circumference is the line around. Circum, like we talk about, like who was the first European to circumnavigate the earth? We talk about that in social studies class. Circum means to go around. And I think of fence like a fence, but that's not what it means. But anyway, I think of it like a fence around a circle. It's the outside of a circle, which should sound a lot to you like the concept of perimeter. And the only reason we don't call it perimeter is because the circle doesn't really have sides since it's round, but it's still the same idea, that outside of a circle. And in fact, when you look for the circumference formulas, you're going to find them in the perimeter section of your formula sheet, okay, because they're so related. So I'm computing the circumference of a circle. That's the length of the line around the outside. Okay, so let's hit up our formula sheet and look at the formula for circumference. Do you see why it's weird? Take a look at that line. What's weird?
3 of them.
Yeah, there's lots of things there. They give you like too much information. So there's actually 2 formulas, and then the third thing is just that same information about pi that I told you. So this is what the line of the formula sheet says. Which one does it list first? Serenity?
C
2 pi r?
equals 2 pi r.
Yeah, so it says C equals 2 pi r, or C equals pi d. And then there's this little semicolon, I think, and then they tell you that pi is approximately equal to 3.14, and they even use the little wavy equal sign that means approximation. So a ton of information. Not all of this is a formula. There's 2 formulas and an extra piece of information here. So we need to, what formula do we want? We've got to make a decision here. I could use this one, or I could use this one. And students go, well, which one should I use? And I'm like, whichever one makes your life easier. So what do you know? Do you know the radius, or do you know the diameter?
We know the radius.
We know the radius. We know the radius. So choose the formula with an R in it. We're lazy. We don't want to do extra work. We don't have to convert radius into diameter if we don't have to. So let's just start with the radius formula. That will be the formula we use. Is everybody cool with that?
Yes.
Okay, so we're finding C. So that circumference is what we're looking for. It will remain C. Numbers don't change. 2 will stay 2. Okay, to approximate or not to approximate? Should we use 3.14 for pi or not?
Yes, because it says to the nearest.
Exactly, to the nearest hundredth. I see some rounding language. I will call pi 3.14. And then I will plug in my R. Notice they're all in parentheses because these 3 things are shoved together and multiplying. And my radius is 5. My R is 5. Super easy. Your calculator will do all the work. I believe we're going to get 31.4 out of this one. Take a look at my rounding directions. They say they want my answer rounded to the nearest hundredth of an inch. How many decimal places is that? Just 2. So we have tenths and then hundredths. The third one would be the thousandths. Good. I'm glad we're reviewing this. Tenths hundredths, because there is no oneths. It's always one less than you'd think. Okay, so that means I want 2 decimal places. Look at my answer. How many decimal places does it have?
1.
1. There's no reason to chop it. It's already shorter than it would have been, okay? If you plugged this in, though, in your TI with the number pi, I'm just going to show you guys real quickly. Remember that there is a pi button in your TI calculator. It's right here on the left in the middle, pi, and you could have hit pi instead of typing in 3.14. Some students do it that way. And if you did it that way, you would end up with more decimals because it would use more digits of pi. Okay, so if you actually had an answer that was longer, you would need to be rounding it right now. Okay, but ours is fine. We're good to go. I'm going to leave it right here. This dilemma probably won't come up for you on the GED as much as it would in your college math classes, because usually the GED is multiple choice. Okay, so we have 31.4. What? Well, this is circumference, so it'll be plain old inches, just like with perimeter. That's a line around the outside. Pretty easy, right?
So far.
Good. The next one is easy as well. Hallelujah. Love it. Straightforward. Just the trickiest part, again, will be choosing the formula. So this one says compute the circumference of a circle to the nearest tenth with a diameter of 11 yards. Okay, so I'm finding circumference. I know the diameter. What formula should I use?
C equals pi and then D.
Exactly. When do I use the one with D? When I know the D. Okay, so I know the D. I know the diameter. It's 11. And so C equals, should I call pi pi or should I use a decimal approximation?
Decimal approximation.
Absolutely. I see that rounding language to the nearest tenth. So I'm going to call pi 3.14, close enough for government work. My diameter is 11. And now I will just go ahead and multiply that out in my TI because I'm so lazy. And I get C is equal to 34.54. Okay, final step is rounding. This time I've been told to round to what place?
The 10th.
The 10th, 1 decimal place. Cut it off here, and this keeps happening. My number that's about to die is not big enough to matter, so boom, I ignore it. We'll just call that 34.5 yards. Straight up yards because it's circumference, which is a line. We good with that?
Yes.
Okay, sweet. Those are the straightforward problems. Yeah, we just straightforward dealt with some circles. Good for us. We are now going to go on and look at trickier problems with different kinds of complications in them. They all have something different going on. And any of them are fair game for the GED, so let's be aware of these tricks. I'm looking at number 5 here. It says, compute the area of a circle to the nearest foot. Oh, I said that twice. So compute the area of a circle to the nearest foot of a circle with a diameter of 27 feet. So students usually do the first step right. They say to me, oh, look, I'm looking for area of a circle. I know the area of a circle formula, so they'll write it down, A equals pi r squared. Okay. Then they'll go, hey, I'm looking for area, and that's equal to, they will use an approximation for pi, which is correct because they did say to the nearest foot to me, permission to round. But then they do this very foolish thing. They just plug in the number 27 blindly without even thinking about it. Anybody want to tell me what this student did wrong?
They didn't add the diameter, the D?
Yeah, they didn't think about the fact that this 27 is not a radius. This 27 that they told me is a diameter. Now, other students will pick out the circumference formula because it has diameter in it. But I'm sorry, diameter or no diameter, circumference formula can only ever give you circumference. It cannot give you area. And so this is when I need that common sense that I was talking about. This is the kind of problem that could show up on your GED where they're just expecting you to know the relationship between radius and diameter. They're expecting if they give you the radius, you can find the thing that you need, the diameter. So let's do some side work over here. Let's draw ourselves a little picture. except I need a pen to draw a picture, not an eraser. Okay, so here's my circle. And we said it has a diameter of 27 feet, meaning all the way across is 27 feet. But for this particular formula, I don't need a diameter. I need a
Radius.
radius. How can I get from that thing they gave me, 27, to the thing I need, radius?
Divide it by 2.
What'd you say?
Divide it by 2.
Absolutely. There are 2 radiuses inside of a diameter, and they're equal. So if I just break that into 2 equal pieces, mathematically, that's the same as dividing by 2. I will get my answer. Now, not all people think of it that way. Did anybody think of it a different way besides dividing by 2? No? Okay, that's okay. Some people will tell me you half it. Same difference. Halving something, taking half of something is the same as dividing by 2. Okay, so I got 13.5 feet. That is my radius. Does that make sense to you?
Yes.
Yes.
That is the number I have to plug in. And there are that is fair game for the GED. It is totally legit for them to not give you the thing you need, but expect that you know how to get from what you have to what you need. Now I'll just plug it into the calculator. Now's the easy part. 3.14 parentheses 13.5 close parentheses and then square with the x squared button. And I get this nice nasty number, 572.265. Everybody good with that?
Yes.
Okay, cool. Do I have any rounding directions to follow?
Round to the nearest foot,
Round to the nearest foot.
which means it's a unit, right?
Yeah, is that you, Bianca? Congrats, sister. That's a unit. So I'm going to hit it off right at that decimal place. Boom, boom, boom. I'm going to ask myself if the number that I'm about to lose, the one right on the cutoff, is big enough to matter. It is not, once again. And so I'll just call that 572. Ooh, my directions should have said to the nearest square foot. By the way, that was just a typo on my part.
Okay.
But anyway, it's going to be 572 square foot. How do I know it's square feet, by the way, even if my directions were typed stupidly? Area is always measured in square units.
Okay.
Wouldn't make any sense for an area to be a line. You can't, I mean, imagine trying to cover a whole rectangle with lines. It just doesn't, you need to squares, 2-dimensional, covering for a 2-dimensional measurement. Okay, so square feet. This problem could show up on the GED, but it doesn't frequently, but it definitely will show up in your high school and college math classes. So if you're going to take any college math classes, you could totally see this too. And here's the reason why I have to tell you a little secret about mathematicians. Mathematicians are obsessed with truth. In fact, if a mathematician had seen my problems up until here, they'd probably be a little mad at me right now because I've been calling pi 3.14 and I haven't even been changing my equal sign to be approximately equal to. We love exact answers in math class. We want our answers to be right on, as exact as possible, not rounded. We're like, maybe in the real world they round numbers so that they make sense, but we prefer truth. Okay, so that means that when you're dealing with your mathematician college professors, they may ask you for an exact answer. Meaning, when I say that I mean an exact answer, I mean instead of approximating pi, calling him 3.14 or 22/7 or any other approximation, you're just going to call pi by his proper name, pi. Because when you call him pi, that's exact. It hasn't been rounded, it hasn't been cut off. It is all the digits of pi without having to write all the digits of pi. Does that make sense?
A little.
Okay, maybe you need to see it done, and I'm about to do it. But the one other thing that I'll tell you is the language we use when we tell you we want an exact answer. We'll often tell you to put your answer in terms of pi. And what we mean by this is just leave pi pi. Don't call him 3.14. Don't call him 22/7, just leave pi pi. So let me show you an example. This one says, what is the area? So I'm going to find area of a circle. And I know the radius, yay. It's a pretty straightforward problem. But here's where it gets tricky. Express your answer in terms of pi. In other words, leave pi pi. Okay, let's give it a try. We'll start with the formula. A equals pi r squared. Now, A is the thing we're finding. It's the area, so we'll leave AA. We were told to put this answer in terms of pi. We were told to leave pi. I am going to just write a pi right there. And everybody has a little few heart palpitations because it seems like scary math, but I promise you this is easier math. Decimals are hard. Pi is easy. Watch what I mean. I know my radius. My radius is not a mystery. My radius is 7, so I'll plug in the 7 for the r, and I'll put a little 2 on there. And here's why I say this is easy math. When pi is not that nasty decimal, pi is just pi, you don't have to worry about him. All you have to do is worry about the number portion, the 7 squared. And you don't need a calculator to square 7. I hope you guys all know what 7 squared is. What is 7 squared, or 7 times 7?
49.
49. Okay, now, usually in math class, when we're going to have a number and a symbol, we write the number portion first. That's called the coefficient. So I'm going to write the 49 first. And you're going to say, what am I going to do with pi? You're just going to put them right there. Pi. 49 pi. That is the exact answer. I don't have to do any ugly multiplication with decimals. I don't have to round. Boom, it's totally true, and it's perfect, and it's beautiful, and it only upsets you if you're not a mathematician. Mathematicians love it. This is a number. You say what number? Well, I could tell you approximately what it was if I were to multiply by 3.14, but it's exactly 49 pi. This is an exact answer. Now, don't mix that up. Pi is not the unit. Pi is part of the answer. I still need my unit. This is an area problem, and so my unit would be in square centimeters, because this was centimeters and area is always squared. Okay, so the final answer here, it really
49.
is just 49 pi square centimeters. Students hate it. Mathematicians love it because it's exact and it's less work. We're lazy. Okay, who's mad at me right now?
Nobody so far.
Oh, that's a miracle. Usually people get pissed at me right now. Kaylee, you okay with my pie too? Sweet. Okay, let's move on then. One more just like that, just so we can get used to it because it's super weird. Okay, this one says, what is the circumference in terms of pi of a circle with a radius of 27 millimeters? So first I'll ask you guys, what formula should I use?
So it would be C
Absolutely.
equals 2 pi r.
Brilliant. I've been given radius, so I'll use a circumference formula that has an r in it because I'm lazy. So C equals 2 pi r, and now I will substitute in what I know. So I don't know C. I don't change symbols. I don't change numbers. I shouldn't say symbols. I don't change equal signs. I don't change numbers. Now, should I use an approximation for pi, or should I leave pi?
Leave pi.
Absolutely. Give me proof from this problem that I'm to leave pi.
It asks for terms.
In terms of pi. Yep, they said keep pi. Okay, I'll leave it in terms of pi. So I leave my pi. And then my radius is not a mystery. My radius is known. What is my radius?
27.
27. Now, once again, students freak out. They're like, how am I supposed to do this multiplying here? These three things are all multiplying. 2 times pi times 27. And the deal is you're just going to leave pi. So all you have to deal with is the numbers. And I hope you guys know by now, there's a name for this property. It is known as the associative property, but it doesn't matter what order you multiply in. So you can feel totally free to just multiply together the 2 and the 27. Those are two numbers you know how to multiply. Let's do it. So 2 times 27 is 54. And then you say, well, what do I do with the pi? You just shove it up real close to the 54 so the whole world knows they're multiplying. So what is the circumference? The circumference is 54 pies. And all mathematicians are super happy about that. We love it. 54 exact, perfect, beautiful pi.
Equals 54 pi mm.
Yes, I haven't gotten there yet, but yes, you're right. It's not the unit, that's the number. So we're going to put a unit on there. And Bianca was wondering if that was millimeters. It sure is. It's mm. It's just plain old millimeters because circumference is a linear measurement. Very nice. And see, all the mathematicians cheered because we didn't have to do ugly multiplication and we didn't have to round. Okay, now one of the problems in math class is that not all students will work things the same way. I know back in some of y'all's poor, horrible high school math experiences, your teacher taught you that you were wrong if you didn't solve a problem just like she did. But just to break it to you, there's lots and lots of ways to do the same math. And as long as you do something true, it's true. True is true, okay? And so that's why there'll be different ways to get to the same problem. So that means sometimes when we have a problem like the next one, if the person who did the problem thought about it in a different way than you did, your answers might not look the same at first until you simplify them. So take a look at what I mean. Number 8. It says, which of the following expressions? These are expressions, meaning the math hasn't necessarily been done yet, okay? Represents the circumference of a circle. So I'm looking for the circumference of a circle with a diameter of 22 feet. Okay, so if I were going to do this problem, I would probably start with my C equals pi d formula because I'm looking for circumference and I've been given a diameter. And if I did that, I would find out C is equal to, notice how all of these formulas have pi in them. Can you guys see that?
Mm-hmm.
So I might not have said anything in my problem about keeping it in terms of pi, but obviously all these answers are in terms of pi. Does that make sense to you?
Yeah.
So pi is pi, and then d would be 22. Okay. Now, if I were to simplify this, all I would ever do is write the 22 first and the pi second. And here's my answer the way I solved it, and yet none of these match my answer, and yet one of them is equivalent. Which one of these is equivalent to my answer?
Is it C?
Is it C? Let's take a look. Let's try to do C and see if it works. So 11 squared, I would have to do that first, would give me 11 squared would give me 121. And if I then multiplied that by 2 times 2, I would get 242 pi. Okay, nice guess, but did it match up in the end? No way. 242 pi's is not the same as 22 pi's. So it's fine to guess, but if you do a guess, check your guess. So anybody else have a guess of what one of these could be equivalent to ours? Kaylee says D. Let's check it out. So looking at D, I have a 2, a pi, and an 11. The only math I can do here is multiply the two numbers together. 2 times 11 is 22, 22 pi. Did their expression simplify to the same as the way I did it?
Yes.
It absolutely did. D is the correct answer. Any idea how come they started different than I did? How come their work looks different than mine? Anybody have a clue? But do you remember how there were 2 circumference formulas?
Yeah.
They used the other formula. They used C equals 2 pi R, and then they probably had to go do the work to find out what R was.
I
know,
see.
if my diameter is 22, my radius would be half of that, 11. Does that make sense? So they went a different way. Maybe they didn't remember my way, but they would have gotten to the same place in the end. Does that make sense to everybody?
Yes.
Good, I'm glad, because this is just the kind of crap the GED might do to you. You're like, I know how to do the problem when I'm doing it my way, but oh no, this is not how I would look at it. So we have to know what other methods might also work. Okay, so looking at number 10, watch out. They can bury these circle problems in word problems that never say circle, never say area, circumference, any of that. And yet it's still that kind of a problem. So let's take a look. Number 10 says, a certain clock has a minute hand that is 8 inches long. How far does the minute hand travel over the course of 3 hours? What are they even asking me? How far does the minute hand travel? What are they asking me about?
How many times does it go around the clock? So
Well,
if
I know
we
how
have
many
3
times it goes around the clock. They said that it's going, it's the course of 3 hours. So then it would go 1, 2, 3 times around the clock in 3 hours. But they're asking me, how far does the minute hand travel? Think of the minute hand traveling around in a circle. Are they asking me about area, or are they asking me about circumference? That's the real question I have for you.
Circumference?
Absolutely. That little tip of the minute hand is traveling a circle around the outside edge of a circle. Okay, and so they're asking me for the circumference. Now let's draw what a minute hand looks like. You guys, does a minute hand go from the center of the clock and go to the outside edge, Or does the minute hand go all the way across?
It's a radius. It's halfway there. It goes from the middle
Exactly.
to the edge.
A minute hand would only go halfway across. And so we really have to just kind of realize that this minute hand is the same thing as a radius. It's 8 inches long. So I'm going to use the C equals 2 pi r formula, the one with radius in it. Looking at this problem, if this were on the GED, it would probably be a multiple choice because it doesn't give you any rounding directions. And I don't remember where I got this problem, but it was GED practice somewhere. But it doesn't give you any rounding directions, and you wouldn't keep it in terms of pi in this style of a word problem. In word problems, we almost invariably use a decimal approximation. So let yourself know that. And why is that? It's because in the real world, it's more useful to have a real measurement that I could go to the store and buy. I want you to imagine you went to Home Depot and said, like, I need 59 pi of fencing. The Home Depot guy would be like, 59 what? He doesn't care if your answer is exact. He cares if he can cut it. You know what I mean? And so word problems are usually decimal approximations. So I will use 3.14 even though there's no rounding directions. You guys okay with that?
Yes.
And now my radius is 8. So I will plug into all of that. 2 times 3.14 times 8. And I have a lot of students who go, oh, look, 50.24. And then again, this would probably be multiple choice if it was on the GED, so you'd get your hint about rounding from the multiple choice. So I'm just going to leave it as is. But then I have all these students who get so excited, they just write 50.24 inches. They're so proud of myself. Yes, they're already shaking her head at me. They're so proud of myself. I finished that problem. I'm such a good circumferencer. And this would suck so bad if you stopped right here. Serenity, what have I forgotten to do?
Round the last number.
Oh, it's actually not the rounding. I don't have any rounding directions right now, so I don't know if I need to round or not. And so I'm just going to leave it be.
Is it really inches?
It is really inches. Circumference is a linear measurement. Go back and reread that problem. What did I forget to deal with?
3.
3. Right, exactly. My minute hand traveled 3 hours, meaning it did that circle 1, 2, 3 times. And I am a very good mathematician, but I am a flaky woman. This is exactly the kind of crap that trips me up because I'll just forget. I'll get so excited I found the circumference and I'll just forget to realize that I went around that circle 3 times. And again, I'm doing this because I went 3 times around the circle in 3 hours. I'm going to multiply the answer I got by 3. Does that make sense?
Yes.
Yes.
Beautiful. So 50.24 times 3 gives me 150.72 inches. And again, if I had a multiple choice answer, they might be rounded. When it's multiple choice, they figure, I don't have to give you rounding directions. You'll figure out the rounding based on the multiple choice. You wouldn't have 2 that could be correct. Does that make sense?
Yes.
Good, good, good. I'm talking and talking today. It's already 3:05. You poor things. You guys doing okay? You can track with me for a few more problems? Okay, so let's try 11. A ceiling fan has a blade of 22. What's that little marking mean? Anybody know?
Inches.
Absolutely, inches. A ceiling fan has a blade length of 22 inches. What is the area of the circle created by the spinning of the fan blades? Okay, so I'm doing an area problem. At least they did tell me that. Okay, and so I will bust out the only area formula I have on the sheet, A equals pi r squared. But be careful, we had better verify that we have R. Do we have R or not? Did they give us what we need? They said that our ceiling fan has a blade length of 22 inches. What's a ceiling fan look like? If I draw the blade, does the blade start at the center and go to the outside? Is it a radius? Or does the blade stretch across the circle? Is it a diameter? That's a good question. I feel like it could go either way, huh? I almost feel like we should be Googling the word blade length. But my ceiling fan, I'm just going to go with the fact that, undo. My ceiling fan goes like this, From the center to the outside? Do your ladies look like that as well? They're like, we don't have ceiling fans. Does that look good to you, Serenity?
Yes.
And so I'm going to guess that by blade length, they mean the radius. Is that cool?
Mm-hmm.
Okay, so let's plug in. A equals, this is a word problem, not a straight up just geometry problem. We're having an application here. We're talking about a ceiling fan in the real world, so we would probably use an approximation for pi. Plug in 22 for r, and I'm going to square it. So 3.14 times 22 squared gives me a nice huge number, 1519.76. And once again, I do not see any rounding directions. And so again, if the GED gave you no rounding directions at all, they would either have you just leave it right here exactly, or it would be multiple choice. So I'm going to leave it right here. And this would be 1519.76 square inches since it's area. Number 12 looks really challenging to students, but number 12 is actually simple. Now you'll see why mathematicians like to call pi pi. Okay, so let's look at this problem. First one we've had of this style. It says a circle has a circumference of 12 pi inches. What is the diameter of the circle? So this time we've been given circumference, we've been given what's usually the answer, and they want us to find that inner measurement, that diameter. So let's start with the formula, and then we'll do the necessary algebra to solve it. But the proper formula here would be which one? What is the formula that relates the circumference to the diameter of a circle? It is a very nice, straightforward formula.
Isn't it pi d and then pi equals 3.14?
Yeah, the C equals pi d. We just need that part.
Mhm.
Now, it's true that pi is approximately equal to 3.14, but we don't need that information right now. And I'm going to tell you why we don't need that information. Notice what they give us. Do you see that the circle has a circumference of 12 pi?
Yes.
That means that I'm going to replace my circumference, my C, with 12 pi. Anytime two things are equivalent, we can trade one out for the other. So I trade my circumference out for 12 pi. It's called the substitution step. Is everybody good with that?
Yes.
And notice that I have a pi on that side. Well, guess what? If I have a pi on that side, I should leave my pi on the other side. So is everybody okay with that?
Yes.
As long as I have pi's, I might as well have pi's all over, okay? And diameter, D, is the thing I'm looking for. Okay, so that was a weird substitution. It's very different from what else we've been doing today, but it is related to last class. Is everybody cool with that? Does that make sense?
Yes.
Okay. Now, I have been told to solve for diameter. Okay, what is the diameter of the circle? We want to find out what D is equal to. That means we need to get D alone. What is the diameter? We're solving for D. Get D alone. I just remind you guys, this is a little bit this. We've gotten into the world of algebra. This is not something we would do with the calculator. This is something we do with our algebraic skills. If I want to get D alone right now, he's not alone. He's multiplying with a pi. See him shoved up against pi? Just
So
like with any other multiplier, any other number in the world, you can get rid of him by doing the opposite. The opposite of multiplying by pi is dividing by pi. Just like you would divide a 5 away or a 27 away or a 33 away, pi is just a number. You can divide him away. Is everybody cool with that?
Yes.
Okay, the rule of solving in algebra is I can make whatever change I want. I can get rid of anything I want as long as I do it to both sides. So I'm going to jump across here and I'm going to divide by pi on this side too. Good. So let's see what happens. On this right-hand side, pi and pi would cancel. You know, multiplying and dividing by the same number cancels, so that my D would be alone. But something cool is going to happen on the left side. Look, again, we have a pi up top and a pi below. They'll cancel. And what will the diameter end up being?
12.
12. That's why mathematicians leave pi pi. It's easier to do the math with as well. So the diameter is just 12. 12 what? Well, that was 12 pi inches, so that'll be 12 inches on the diameter. And in fact, that is where pi comes from. Pi is the relationship between the diameter and the circumference of a circle. Okay, a circumference of a circle is pi times as long as the diameter. That feels weird, but it's a real live number that shows up in every circle in the entire universe. It's the relationship, the ratio between a diameter and a circumference. Okay. You mad at me? How did that go? It was weird, but it was easy, I hope. Yes?
Yes.
Okay.
So it's done differently.
Yeah, exactly. And so we panic because it looks so funky, but the math really isn't that hard at all. In fact, it's easier. Don't need a calculator. So 13, we'll try this one. A circle has an area of 22.4 square centimeters. No pi. We'll have to use a calculator, but at least it'll be familiar ground, huh? Okay, what is the radius of the circle to the nearest tenth? Okay, so I need a formula. I need a formula that relates the first thing I've been given, area, to the next thing I've been given, radius. Any ideas?
You have the area.
Yeah, so I definitely need an area formula.
So we need the area of a circle then?
Exactly. There you go.
And that is A equals pi r squared.
Very nice. Now we'll plug in what we know. So what do we know? We know the area is 22.4. So underneath the A for area, I'm writing 22.4. Now equal sign, we'll stay equal sign, and I have my decision. Keep pi pi or use a decimal approximation of pi?
Keep pi pi.
What part of the problem made you think to keep pi pi?
I have no idea, to be honest.
Yeah, okay. So that's why I asked. Okay, so this is what I see here. Take a look, Serenity. Look at this language. See how it says to the nearest? Oh, I'm on the wrong problem. Let me try being on the right problem. That'll help.
I
Let's
think
look at number
it's getting
13.
late for you.
What? We'll cut all that out so I'll look smarter. Okay, here we go. to the nearest tenth. Okay, see that language in the right problem? That says to the nearest tenth. I see rounding language. Anytime it says to the nearest anything, that's some rounding language, which is a big clue that I should use a decimal approximation. I'm going to use 3.14 for pi. You cool with that?
Yes.
Okay, so let's call pi 3.14. And radius is the thing I'm looking for. I'm looking for r, so I'll leave r. And I won't change any operations, so my square will still be there. Now, this is a trickier problem. I've got a little bit of work to do to get r alone, but can you see that my r is currently encased in numbers and operations, and we need to work to get it alone? Okay, this is why I asked you to do your order of operations before you covered this. Because one thing important that I bring up in the order of operations videos and the solving two-step equations videos is that when you're solving, you actually work the order of operations backwards. So you work your gemma, groupings, exponents, multiplication and its inverse, addition and its inverse, you work it backwards. So I'm going to remove the 3.14 first. The reason why is because 3.14 is multiplying. So I have to take away things that are multiplying before I take away exponents because I work gemma backwards when I solve. Okay, so I'm going to divide both sides by 3.14. So I'm dividing both sides of my equation by 3.14 in my goal to get r by itself. So on this side, multiplying by 3.14 and dividing by 3.14 cancel, yay. So r squared is r is getting more and more alone. I only have r squared left on that side. And now on this left-hand side, there's some work to do. 22.4 divided by 3.14. Now, when you do that in your calculator, you're going to notice that you get a long, ugly number. Now, I don't want to write my whole long, ugly number down because I'm so lazy, but I also don't want to lose that number. So even though I don't write it all down, I'm going to keep it all in my calculator so that I'm still working with it in my calculator. So I'll just write down like 7.13 ... right here. Okay? But I'm keeping that long, ugly number in my calculator. Okay, now R is almost alone, but there's a square to get rid of. And we've done that before. Does anybody remember how to get rid of a square? What's the opposite of square? Take note of that because it definitely will probably show up on your GED in one form or another. The opposite of square is square root. This happens in these kind of problems, and it also happens in Pythagorean theorem problems a lot that you have to deal with this. So the inverse or opposite of square is square root. Okay, and so I'm going to take the square root of both sides of the equation. Okay, everybody cool with that? So on the right-hand side, square and square root are going to cancel, leaving R alone. And the left-hand side is the work to do, and I want you to know how to do this in your TI. In your TI calculator, you can actually take the square root of the last thing you typed without doing a lot of typing if you know how to use your calculator. So here's how we're going to do it. I need a little bit of room here to write. So what you're going to notice is that above the x squared button in green is a square root. That's what I want. But anytime there's something in green, you have to hit the second button first. So hit second, the x squared button to get the square root. And then I want to take the square root of the last answer. So I'm going to hit second again. And the minus key, because right above the minus key in green is written A and S. That stands for answer. So second, square root, second, answer, and it tells me that the square root of about 7 is 2.6709, on and on and on. You should, whatever you're doing right now, if you have a TI-30X, and I'm not just talking to my ladies, I'm talking to the whole internet, you should pick up your calculator right now and try to do that, because it will suck. If you go to take your test and you're like, I know Kate did that somehow, and you can't remember how to use your calculator. So second, square root, second, answer. And I get 2.6709. Am I done with this problem? Serenity's like, dear Lord, I hope you are. What do I have to do still with my answer?
Don't you have to do the nearest tenth?
Exactly. It says to the nearest tenth. Go ahead and follow those directions and give your answer rounded to the appropriate places. So the 10th place is 1 decimal, so I'll round it to there. I'm about to chop off and lose a 7. 7s are definitely 5 or higher, big enough to matter. And so I'm going to bump up that number before it to 7. So up from 2.6 to about 2.7. And I get 2.7, and we're talking about radius, and radius is just a line, so it'll be 2.7 plain old linear centimeters. Not square. I know that there are square centimeters in the problem, but that was the area. The radius itself is just a line, so it's in centimeters. So last one, hallelujah. I know you guys are done with me already. I had so many circle problems, but I want to make sure we get to as hard as they get on the GED. They definitely get this challenging on the GED. So number 14, I am trying to trick you. I'll just warn you in advance. I'm trying to trick you just like a math teacher, okay? Let's look at number 14. It says a circle has an area of 1.45 square feet. What is the diameter of the circle to the nearest hundredth of a foot? The first challenge here is to find the right formula. Many students choose the wrong formula. Many students go, oh, look, I have diameter. I'm going to use this formula, C equals pi d, because C equals pi d has the diameter in it. Anybody know what's wrong with this line of logic? So take a look here. What do we know? We know that the circle has an area of 1.45 feet. Now, yes, I agree that we're looking for diameter, but unless you know how to get from area to circumference, you're going to be screwed with this formula, because this formula does not have an A in it. It's not an area formula. It's a circumference formula. Can you guys see that?
So then do we have to figure out how to get from the circumference to the diameter or vice versa?
If you tried to use this one, you would, and we don't have like a shortcut path for that. So this one's a bad choice. Let me show you a better choice of a formula. And I just really wanted to do that because that is the biggest error I see students make. Pick that formula because they know they're looking for D, and it's the only formula they can find with a D in it. Okay? You have got to, if you are given area, you have got to just go ahead and use an area formula. Now, this is why students get mad at me. They say, but Kate, the area formula is A equals pi r squared. There's no D in it. How am I going to use this? And I'm like, guys, you're supposed to know the relationship between radius and diameter. That's the only relationship in circles that you're supposed to have memorized. Remember, we did that at the very beginning? So we can use this thing to find radius, and once we know the radius, we'll take an extra step to get us to diameter, and that will be from our own knowledge. Does that make sense?
Yes.
Okay, let's give it a try.
How come you don't use the one with diameter?
Yeah, it's because the one with diameter features circumference, and I don't know the circumference. And I don't know how to get from circumference to area. I don't have that relationship memorized. If I did, I could use it, but I don't. But I do know the relationship between radius and diameter. So it's super easy for me to convert back and forth between radius and diameter, no formula necessary. Make sense?
Yeah.
Yeah, maybe. Let's try it and see if working the problem helps us to understand what I mean. So I have this area formula because I've been given the area. And I'll plug in what I know. I know that the area itself is 1.45. So my A will become a 1.45. I don't change equal signs. I see some rounding language to the nearest hundredth. So I'm going to call pi 3.14, sorry. I'm going to use it.
Before we find the area and everything, if we're using radius, shouldn't we first try and find the diameter and then plug in those numbers?
Good question. If I were plugging it in, that's what I would do. But I'm not plugging it in right now. I'm finding it. Do you see how I'm going to find this formula right now is going to find R? See how the A is gone? I don't know A anymore.
Okay.
Yeah, so I'm going to find R first, and then once I know what the radius is, I'll go to the diameter. So if I knew the radius, I could go to the diameter, or if I knew the diameter, I could go to the radius right away, but I don't know them yet. So I'm going to do the work to find radius, and then once I find it, I'll use that to get to diameter. Okay, so we're going to have to use our algebra skills just like the last problem in order to solve this. I need to get this R alone in order to find out what it's equal to. So the first thing I'll do is divide both sides by 3.14. Okay, so if I, on the right-hand side, multiplying by 3.14 and dividing by 3.14 cancels so that my R squared is left. And on the left-hand side, 1.45 divided by 3.14 is something gross, but I don't care if it's gross. I'll just write down a few digits here like I did before, and I'll keep the rest in my calculator. Now, once again, R is not by itself yet, but I can get it by itself. How, ladies? What is the opposite of square?
Square root.
Square root. So I'll take the square root of both sides. In algebra class, we're allowed to do whatever we want as long as, when we have an equation, as long as we do it to both sides. So square and square root cancel, leaving me with just R. And there's the math to do, and we just learned how to do that in our calculator. Second square root, second answer. And it tells me that R is 0.6795, Okay. And that's my radius. Now, I'm not going to round yet because I'm not to my place that I need to be yet. Right now, this is an R. This is a radius. And they did not tell me to find R. And that's why I say this is as tricky as these problems get. They told me to find diameter. And this is the relationship we're supposed to know. We don't get a formula for it. What's the relationship between radius and diameter? You guys remember?
Right. So would you multiply that radius by 2?
Brilliant. Brilliant. A radius goes halfway across. Okay, so if I wanted to get a diameter, I would need 2 radiuses. So I'm just going to take that answer and I'm going to multiply by 2. I'm going to times my radius by 2, and I get 1.359, yada, 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 equals my diameter. And now that I'm at my final answer, now I round so that I don't lose information. So rounding directions say to round to what place?
Nearest hundredth.
Hundredth, 2 decimal places, tenths, hundredths. So I'm going to cut it off right after the hundredths place. I'm going to consider the next number, the one about to die. That's the 9. It is big enough to matter, so its last final act before I get rid of it will be to bump its buddy up. This will go up to 1.36. 1.36 what? 1.36 feet. What a weird problem. That is as challenging as it gets. And again, if you're trying to memorize, I do these kind of problems like this, you're seeing that more and more. We couldn't memorize all the different ways they could phrase a word problem. You really have to go looking to the word problem for the clues in how to solve this. Okay. Okay, so 14 is as hard as it gets. So you know how I do leveled practice when I post this up on the website? I'll do the 14 as the advanced problems. Those are definitely the most challenging here. Okay, thank you ladies for joining me. Sincerely, I know I joke every time I say it, but I hate talking to myself. So love it when you guys show up for class. Appreciate you. Bye-bye.